Here we have a SAT math problem. Okay, let's go to the question. In triangle ABC, angle B is a right angle and the length of AB is 456 millimeters. If the cosine C equals to 7 over 25, what is the length in millimeters of the line segment BC? Okay, let me draw a right triangle. Here I have drawn a right triangle. Since the question says angle B is a right angle, let's take the vertex B at right angle over here. And let me take the vertex A over here and C over here. Now let me consider the interior angle at the vertex C because we have value for the trigonometric ratio cosine of angle C. Okay, considering this interior angle, we have to take this side AB as opposite side because this side is opposite to this interior angle. Okay, now let me mark this one as opposite side. And we know that this is hypotenuse because it is opposite to the right angle. Okay, hypotenuse. And the name of the third side BC is adjacent side. Okay, now let's consider the information we have over here. That is cosine C equals to 7 over 25. According to Seccato, the formula to get the value of the trigonometric ratio cosine is adjacent side divided by hypotenuse. Now to get the actual length of the adjacent side and actual length of the hypotenuse, we have to multiply the terms of the ratio over here by the same non-zero number, say x. When I multiply this 7 by x, I am getting 7x. When I multiply this 25 by x, I am getting 25x. So this 7x is the actual length of the adjacent side and this 25x is the actual length of the hypotenuse. Okay, here let me take this 7x over here for adjacent side and take 25x as the length of hypotenuse, that is for the side AC. Okay, and for AB, we have the length over here, that is 456 millimeters. Okay, let me mark it over here. Since it's a right triangle, we can use Pythagorean theorem. So Pythagorean theorem says sum of the squares of two legs equals to the square of the hypotenuse. That is 7x the whole square positive 456 square equals to, so I squared the two legs over here and added them. It is equal to the square of the hypotenuse, that is 25x the whole square. Okay, now we have to find the value of x in this equation. Once we get the value of x, it has to be multiplied by 7 to get the length of the line segment BC. We can solve for x in this equation using Desmos. Okay, now let me give this equation as input over here in Desmos. That is 7x whole square positive 456 square equals to 25x the whole square. Okay, since we have the variable x in the equation over here, we have to consider the x-intercept of the graph. Okay, at this x-intercept, consider the x-coordinate, that is 19. So this is the value of x in this equation. Okay, here I got the value of x, that is equal to 19. Okay, we know that this 7x is the length of the line segment BC. Okay, so BC equals to 7x. Let's plug in this 19 for x over here. Then we get 7 times 19. 7 times 19 is 133. Since we have the length of the line segment AB in millimeters, we can consider the length of the line segment BC also in millimeters. Therefore, the length of the line segment BC is 133 millimeters.